Alright, starting 4-1, quadratic functions, transformations, aka parabolas. Ben, start off for us reading the icons.
I can explain the parent function for quadratic functions is the parabola f parenthesis x parenthesis equals x squared.
Okay, Chris, hopefully you can read the next one a little faster.
Yeah. I can graph a quadratic function by hand by creating a table of values.
Sweet, Johnny, you got the next one.
I can explain, describe, and graph transformations that will affect the parent function, i.e. horizontal and vertical translations, stretches, and compressions.
Sweet, Andrew.
I can explain that the minimum or maximum of a quadratic is called the vertex.
Last one, Deshaun.
I can identify rather the vertex or of a parabola will be the minimum or maximum by looking at the equation.
Nice. Okay, pretty much this is a little bit of a repeat from a chapter and a half ago where we talked about translations. Vertex. Anybody know what a vertex is? Two lines meet. Where they meet, where something changes directions, where there's a minimum or maximum. Here, this is where my graph changes directions. That is a minimum. And the middle one, this point right here, 0, 3, is where I have a vertex. My graph is a max. My graph changes directions. What's the point of my vertex in the last one?
Minimum, right?
What's the point?
2, -3.
2, -3, right here. Sweet. Alright, you got some blanks to fill in. First one is the function of a quadratic function. It's kind of like the standard function right here. F of x equals ax squared plus bx plus c. Then at our vertex, we have this thing called the axis of symmetry that goes through our vertex. It's a line where I can fold my parabola and it will mirror the other side. So parabola is symmetrical around my next blank axis of symmetry. Instead of writing out axis of symmetry, a lot of times I just write AOS because it's easier. Alright. Everybody besides Ben good?
Yes.
Okay. Alright. The first thing we're going to do is decide which function or equation is a parabola. Does anybody know what we look for in equations? How do I know if it's parabola?
Square.
Squared. So it has to have a square. If it has a square, it's parabola. Is the first one a parabola?
No.
How about second?
Yes.
Yeah, circle it. Oh boy, that's a horrible circle. How about the third one?
Yes.
Yeah, circle it. Fourth one?
No.
No.
Get it out of here.
Get it out.
Be gone.
Build a wall.
Yeah.
Are you agreeing with that?
Alright, third one says cross out the functions whose graph is not a parabola. Is my first one a parabola?
Yes.
Yeah, so we'll leave it. Second one, is it a parabola? Cross it out. Third one,
Yes.
leave it. Last one,
No.
cross it out. Okay, quick little insight. If there is a squared attached to a number, that does not make it a parabola, okay? Perfect. It has to be attached to the variable. The squared has to be attached to the variable. Alright. I think we've dealt with x squared a couple times. That's our parent function. This y equals x squared. Its vertex is at 0, 0. which means its axis of symmetry is the y-axis, or x equals 0. And pretty much, you guys all know what the table, let's go back up. I don't know if you want to put this in there, but the table for your parent function goes 0, 0, 1, 1, 2, 4. Those are our squares. So that's kind of what I like to think of as the standard shape. So if in your table when we do other stuff, you see 0, 1, 4, it has the same shape as parent function. It's just moved up, down, left, right, whatever. Okay. Alright, so let's do this first problem. It says, what is the graph of y equals negative 1/3 x squared first? Any brave soul want to guess what the vertex is?
0,
0, 0. Look at my little geniuses. Vertex is 0, 0. So I am going to plot that on my graph, put a dot at 0, 0.
You just kind of like said it.
Because of the first orders of the thing.
Yeah, if you put 0 in a table, what do you get out? What's 0 times
0.
0 squared is 0. 0 times negative 1/3 is 0. So you get 0, 0. How about anybody want to?
that 0,
Is it also 0?
Yeah, it's 0, 0.
Oh, that's 6, 0.
Symmetry, for that to be 0, 0.
That makes a lot.
Chloe, you were saying the axis of symmetry had to be what?
0, 0.
0, 0 is a pointer. Axis of symmetry is x equals 0. This line right there, you were on something. It was real good.
That's a first.
No, no, not first, but.
For me.
Okay.
That's right, accepted.
Alright, the next thing I'm going to do is draw a table. Sometimes I get confused, so I like tables. It says, step 2, find and plot 2 points on one side of the axis of symmetry. The nice thing about axis of symmetry is if I just focus on the right side of it, once I get it done, I just can copy on the left side. So I like to pick numbers that are small, but that are also nice. So I'm going to pick x of 3.
Why?
Yeah.
Because
Why
I'm
would you
just
choose
super
such a number?
genius.
Why would you choose that number?
If you put 1 in here, you're going to get a nasty fraction, and ain't nobody like fractions. So,
That's a little bit. That's a little bit much.
I know why you picked 3.
ooh, Cam, if I put in 3, what do I get out?
4.
Negative.
What's 3 squared?
9.
What's 9 times a negative 1/3? Negative 3. It's a nice little number. So I
that's
go
why
over
you
3.
choose
I understand. I don't.
Okay, shh, enough. I'm going to go down by 2s or we'll never fit.
Yeah. Whoa. That's. Whoa.
Wait, what?
I'm going to go over by 1s, down by 2s. If you want to continue to draw lines, that's fine.
Do we not have to do parent graph?
Over by 1 and down by.
That's so confusing. Why wouldn't you just have the same for both sides?
Okay, you can do that, that's fine.
Why did you only go down like 1 instead of?
I went down 3.
I can see what
Because I went by 2s.
Oh, you went by 2s.
Right.
Sorry.
Okay, next nice number that I'm going to plug in. 6. 6 squared, 36. Negative 12. Which is the very last one. Which is why I went by 2s.
You are a genius, Liz.
I know.
Oh.
Okay, now that my right side is done, all I have to do is go back to my vertex. I'm going to go left 3, down 3. So that that point is mirrored. And then left 6, down 12. Then we draw a nice pretty line. Make sure it is curved. Ooh, that was perfect.
Beautiful.
That is perfect.
That note.
And I heard not to be.
Why is it how you got those lines? Like, where do you start at? I'm sorry.
What?
X equals 0.
I can see why I did this with this class.
Okay.
Like, I'm going up.
So I heard Chloe, I believe it was, say it's a wide one.
Oh, yeah.
Much wider than this top one, right? We're going to talk about that in a little sec. But we've dealt with fractions outside before, right?
No.
Yeah.
Yeah,
Maybe.
it made stuff wider.
Yeah, it did.
It did.
Oh, why?
Alright, does everybody have a graph down?
Yeah. Let's just
Okay.
say yes.
No.
Alright, next one. Our parent function again, x squared. Every time we have a parabola, we use parent function x squared. I want to graph x squared plus 3. So we're going to start with a little table. I'm going to choose x0. If I put 0 into this equation right here, what do I get out?
3.
3. So I plot the point at 0, 3. Missed a little. Which means my axis of symmetry is still x equals 0.
One, you get 4.
1 I get 4. You're like a little mind reader.
And 2, you get 7.
Yeah, super power.
Look at this math, man.
Did you have to do the...
Okay, I have my right side done with my points. I'm going to mirror them all on the left and draw my nice parabola.
What are you doing?
What even is
Yes.
Oh, wait, so
normal problem.
I think she got her second point because it's up one over one. I'm supposed to be there.
If you plug in 1 to x squared plus 3, what do you get?
Yeah, 1 times 1 plus 3.
Dude,
Oh, and then you just go over one up four and then plot the point.
Yeah.
Not yet, not yet. A little bit more.
Dave?
So, question. It asks, how is it a translation? What's the difference? Normally we go like this.
Without 3.
That's it. Just like before. Only thing we did is go up 3 thanks to that 3.
Yeah.
Jeez.
So using what we know before from chapter 2, in problem 2b, what do you think is going to happen with that 4?
Right 4.
Ooh,
Wait.
we got guesses.
Congratulations.
That wasn't a guess.
Do you want us to?
Oh.
Yes.
No
What a guy.
Let's double check. If I put in 4 for x, what do I get out?
What's our graph?
0.
Wow,
Plot
that
it.
was a guess. Wow.
If I put in 5, guys,
Invisible sniper.
if I put in 5, what do I get out?
-1. Right? No.
Positive one.
Positive 1.
1.
Dude.
Come on, man. You gotta set
If I put in 6,
You get 2. No, 4, because then you square, right?
Alright.
Oh my goodness.
Mata. This is hard for me.
You just say 2.
It's Monday. Get over it.
It's Monday.
Chill.
Monday.
guys, enough. Seriously. Enough. Okay, so I have my vertex here at 4, 0. I have my axis symmetry at 4. All you gotta do is mirror your points and draw our curved line. And we are correct, it went right over. Okay, good there?
Yes.
Okay. This little table is pretty much what we talked about before. Your A, the thing out front, which we'll talk about in a sec. If it's positive, we're opening up. Negative, we open down. If it's bigger than 1, we get narrower. It's a vertical stretch. If it's a fraction between 0 and 1, we get wider vertical compression. Okay? If, I think these are blanks, if A is less than 0, oops, I missed the first one. If A is greater than 0, it opens up and we have a minimum.
Oh, is this the shading technique?
No.
Alright, I've done those, so never mind.
Well, if it opens downward, our A is less than 0 and we have a max. And we'll talk about that more in about 2 seconds.
Gotta keep up.
Oh, that wasn't your blank. We hadn't gotten there yet. Alright, vertex form of a quadratic. This is super important. It is f of x equals a times parentheses x minus h squared plus k. That's what we call vertex form. It is, I don't know, I consider it kind of standard form. Easiest way to graph is using this little formula. From that formula, we can get the axis of symmetry real nice. X equals h, and our vertex is just the point HK.
That's vertex.
Yep.
So I know.
Again, it kind of looks like what we did with absolute values in chapter 2. This is what I was talking about. Your blanks. A is bigger than 0. A is less than 0.
We can't see.
Our boxes come with
So if A is bigger than 0, that's the thing out front. So if it's positive, we open upwards and we have a minimum. It doesn't go any lower than our vertex. If our A up front is negative, we open downwards and we have a maximum. Doesn't get any bigger than that point. Alright, we got our blanks filled in?
Yes.
Okay. So using that standard form, a times x minus h squared plus k, again notice that it's a minus, so if we have our vertex h, the standard form is for it to be a minus. So if I have a plus in there, my h is negative. Okay, kind of like before with the absolute values.
So it's opposite.
Opposite, yep. Only on the inside though. So here we have a function in vertex form. From this we can find our vertex real quick. Any takers?
-1, 4.
-1, 4, good. Inside I have the +1, which means it's negative. Outside the +4, leave it. So the only one you have to change is the one inside. Okay. Axis of symmetry,
X is equal to -1.
x equals -1. You just pretty much copy down your x coordinate. AOS, axis of symmetry.
Okay, yeah, I thought you said something else there.
Right.
This is centralized.
Okay, here might be the most confusing part of this. It's not that bad.
Just slow down.
This one's out.
Teach us like we're not supposed to be in this class.
Yeah.
Then we'll understand it, I promise.
I promise.
We only got 15 minutes a day.
Oh.
Yeah.
That's too bad.
Well,
Okay.
Like, extended then?
To figure out
How do you just
if
put it-
we, how about we stop talking and then we can listen.
hey.
To figure out if we have a min or max, you will look out front first, okay? You look at the sign up front. Ours is negative, okay? Since it's negative, that means we go down.
maximum.
So I have a maximum, good.
It's gonna be confusing to remember. So if it's going down, it's just gonna be maximum. That's kind of confusing.
To figure out what our maximum value is, we take our y coordinate of our vertex. So to find out axis of symmetry, take your x. To figure out the max min, take your y. You're pretty much just reusing information that you have in a different way.
So it's maximum and minimum of -1. What?
No, there is no minimum because we have a maximum. Okay, domain. Does anybody remember what domain is?
X, right?
That's our x, yep. There are no restrictions on our x. So we use that fancy R thing, or you can write all reals.
Oh no.
Pretty much in this section, there will never be any restrictions on our domain
So we always put all real numbers.
for this section.
No.
Okay, domain is x, range is y. Well, I said I had a max, right?
Yeah.
So my range has to be less than 4. So my y has to be less than or equal to 4. Again, you're pretty much taking the information and stating it in a different way.
Wait, wouldn't it be X?
No, because domain is X.
Oh, because it's your max.
Because it's the max, man.
Where's
Yeah.
So it's also, it makes sense now.
When would it ever be
You just want to
greater
put it
than
together
1?
in your head, right? It's like a big old puzzle.
When we have a minimum.
You're a puzzle.
So when our parabola is flipped like that, we have a minimum and our y's have
At
to be
least I
bigger.
don't have cancer.
Well, that's super rude.
I'm just happy I don't have cancer.
Sweet.
What?
Okay, next problem.
Yeah, what's wrong?
All right, vertex. 3, -5, good. My axis of symmetry is x equals what?
3.
3. Good. To figure out min or max, I look out front. My sign is a positive, right? So do I open up. Since it's positive, that means I open up. So do I have a min or max?
Minimum.
Min.
Negative.
No.
A minimum of what? What's my lowest value? Good. -5.
So does that mean y is greater than or equal to -5 for our
Domain deals with x's. Do I know any restrictions on my x's? No. So I got my all reals. But like Andrew was saying, my range has a restriction. My minimum is at -5, so I need to be
Greater than or equal to.
good. Greater than or equal to -5. We're not done.
How's there not a
This
limit
is D2.
to x? Because what's the 3?
Because these go on forever, so they slowly go left and right forever. Okay, other questions? Yep.
How? What would be our lowest greater domain, like other than all real numbers?
So there are parabolas
I'm just trying to move.
that go this way, and you can put a cap on them, but in this section we don't.
You're the one that's behind.
When we get there,
That's the reason I call you Windows.
Hey, shh. Shh. More notes.
What? It says
Day 2.
Yeah, we are doing them in 2 days, in 1 day.
This is
Yeah.
I barely get this.
Okay, chill. or you're gonna have literally 0 work time.
Oh, and we.
Okay. Vertex. Nothing different. Same thing we did about 2 seconds ago. What's my vertex?
-2, -5.
Good. -2, -5. If my vertex is -2, -5, my axis of symmetry is x equals -2.
So that limits our x, right? No.
So we plot the point -2, 5, -5.
Oh, I see. Okay, alright.
Our axis of symmetry always goes through our vertex. You know, maybe you don't understand.
You literally catch me at the time.
So x
You
will
just
never
turn
be
around and
limited
ignore me.
because we don't have sideways people, right?
No, we don't.
Okay, now we gotta use 2 points. I always go to the right. My vertex x is -2, so I'm gonna use -1 and 0. Where am I plugging that in?
Into the first one.
X.
Put it in for x in this equation right here. If I do that, I get out what for y?
Do you get -5?
What's -1 plus 2?
-1.
What's 1 squared?
1.
1 times 2?
2.
2 minus 5?
That's too much.
And then you get -5.
No.
For 0.
No.
And then 0 should be 3, right?
Yes. 0 plus 2, 2, 2 squared, 4. 4 times 2, 8. 8 minus 5.
3.
Oh, I don't know.
This might be a stupid question, but I missed it. Over our vertex, why is it a -2?
Just like when we did absolute values before.
Yeah.
This is our x, and the minus makes it a plus. The plus makes it a negative.
Oh, it's just the reverse. Gotcha.
Yep.
Okay, thank you.
Okay, and then mirror your points over your axis, and draw your parabola. Oh, I missed the point. Bad. That's okay.
Kinda looks like a Funko Pop.
Mine was like perfect.
Mine was not.
What?
All right, we all got a graph.
Yes.
Okay. Next thing we got is this equation: 2 times parentheses x plus 2 squared minus 5. Do I have a negative out front?
No.
So do I reflect over the x-axis?
No.
No. What does the 2 mean?
Which one?
This 2.
Oh.
Means it stretches, right?
Yep, stretch by 2. Good. What's my vertex?
2, -5.
Close.
-2, -5.
Oh, because I got to reverse them. Got it.
So that means I'm going left or right 2.
Right.
Right.
Left.
Right.
No.
Right.
Left.
You're going left.
100%.
Right. Right is
What?
Left.
Yes.
Negative will be that way.
Yes.
Down 5.
I don't know. Call machine back.
Okay, next one we gotta come up with it all on our own. Do I have a negative up front?
Yes.
What does it mean?
Down. It says down.
It means it reflects over x axis. What does the the 2 mean?
It means that we're stretching but negatively, right?
No, the negative is our reflection.
We're reflecting and it's stretched.
Right, so it's just stretched by 2. Not a negative 2, just stretched by 2.
Only catches
What does the 3 tell me?
It's pon. Oh, wait.
We know, goes right 3.
Yeah, it goes right through.
Right 3. What's the 1 tell me?
It's
Goes
up.
out 1.
Up 1.
That's a vertex, right?
Almost done. 1 more.
Oh, I wish I was really here for the reflect and stretch, but it's still confusing.
Okay, last one. It says the graph shows the jump of a dolphin. The axis of symmetry is x equals 2, and the height is 7. If the path of the jump passes through the point 5, 5, what quadratic function models the path of the jump? So it tells me axis symmetry right here. So my vertex is what?
2, 6.
Close.
7.
2, 7.
Dude, what is wrong with me today?
Hey!
Vertex is 2, 7. It says it goes through 5, 5, which we can tell right here. 5, 5. So I have a point. 5, 5. Okay. That's everything we know from our paragraph. I'm going to write this up real quick. Our standard equation looks like this. Vertex, I plug in for what variables? What letters? The vertex.
H and K.
H and K. So far, I have y equals a times x minus 2 squared plus 7. All I did was plug in our vertex into that standard equation. Okay. So I've used the vertex. Not helpful anymore. What can I do with my point?
You put the X and the Y.
Oh yeah. H. Put X, our 5 in.
And then the Y.
Y, our 5 in. So this should look like 5 equals a times 5 minus 2 squared plus 7. I now only have one variable that I can solve for.
A.
Kane says simplify. What is 5 minus 2?
3.
What is 3
9.
squared? 9. So I have chill. A 5 equals 9a plus 7.
Subtract 7.
Subtract 7. Negative 2 equals 9a. And we get this nasty
Yo.
fraction,
Terrible.
negative 2 ninths. But I don't care if it's good, I don't care if it's bad. All I want to know is the equation. So plug it back in. Plug our vertex in, and we're good to go. So I have y equals our a, negative 2 ninths, x minus 2 squared
Yeah.
plus 7.
Okay, so so then we simplify again and solve it for y.
No,
Oh,
we're done.
okay. We're done?
Hold on, slow her down.